Everybody, this is the 2016 free response question number 4. So we're given this differential equation right here, and in part A, we're asked to sketch a slope field for the given points. So the first thing I notice is that because the y squared is in the numerator on the top, we know that anytime the y is 0, we're going to have a slope of 0. So for this point right here at 0, 0, and for this point right here at 2, 0, we know the slope is going to be 0. So those are nice and easy to sketch. Then at the point 0, 1, if we just plug in the values, we can find the slope. So if we plug in 0 for x, we would have a negative 1 on the bottom, and 1 for a y means 1 squared on the top, so we would have a slope of negative 1. If we plug in the point 0, 2, we would have 2 squared on top, which is 4, and then over negative 1, so we would have a slope of negative 4. So we really just need to show that it's steeper than the negative 1 that we drew. And then moving over to the point 2, 1, let's see, if we plug in 1 on the top, we would have 1 squared, and then on the bottom, we would have a positive 1, so we're going to have a slope of positive 1 right here. And then if we plug in the point 2, 2, we'd have 4 over 1, so we'd have a slope of positive 4. So again, it needs to be steeper, and it really should just be the opposite of the point of the slope at the point 0, 2. For part B here, let's see, we are given this initial condition of 2, 3, and we want to write the equation of the tangent line and then use it to approximate. So for our tangent line, we know we're going to need a point, which we've got as 2, 3, and we're going to need the slope. And we know that the slope of the tangent line is just the derivative evaluated at that point. So we're going to do dy dx evaluated at the point 2, 3. So we would have 3 squared over 2 minus 1, so we would have a slope of 9, which means our tangent line is going to be y minus 3 equals 9 times x minus 2. And if we go ahead and rearrange that and make it L of x, we'd have 3 plus 9 times x minus 2. So this right here is our tangent line. And now we're going to use that to do our approximation. So approximate at x equals 2. So we're going to do um, f of, or I'm sorry, 2.1 is what we want. So f of 2.1 is approximately equal to L of 2.1. And so that means just plug that in. So 3 plus 9, 2.1 minus 2. So we'd have 3 plus 9 times 0.1. And hopefully you guys are with me when I say then that that is approximately 3.9. All right, and for part C here, we need to solve the differential equation. So we need to start with our differential. And we need to separate the variables. So when we multiply by that dx, we then need to divide by y squared. So we would have dy over y squared is equal to 1 over x minus 1 dx. All right, and now we're going to go ahead and take the integral on both sides. Now on the left side here, we know that this is really y to the negative second dy. And on the right here, this is something you're going to have to recognize. It's 1 over a quantity that's to the power of 1, which means the antiderivative here is going to be the natural log of the absolute value of x minus 1 plus c. And on the left side, we're going to add 1 to the exponent, multiply by a negative 1 to take care of that chain rule. And so it's really negative 1 over y equals the natural log of the absolute value of x minus 1 plus c. And now we can go ahead and plug in our initial condition to solve for c. So it's going to be negative 1 over 3 equals the natural log of the absolute value of 2 minus 1 plus c. Well, 2 minus 1 is 1. The natural log of 1 is 0. So we end up getting negative 1/3 is our c value. And so now we can just go ahead and solve for y. So negative 1 over y is going to equal the natural log of the absolute value of x minus 1 minus 1/3. Well, if we get rid of that negative sign, we can make it 1 over y is equal to negative natural log of the absolute value of x minus 1 plus 1/3. And then since it's 1 over y, we can actually just take the reciprocal and just make it y equals 1 over negative natural log of the absolute value of x minus 1 plus 1/3. So technically, we're looking at all of this being over 1, and we just take the reciprocal of both sides. And so this would be our answer right here. Now, I don't usually like to leave fractions in fractions, so I probably would have done it a little bit differently and gotten a common denominator and stuff. But this would be a final answer. If you were to get a common denominator, your answer would end up being y equals 3 over negative 3 natural log absolute value of x minus 1 plus 1. So either way that you want to do it, if you want to get rid of the fraction, you can get rid of the fraction. If you want to leave it, you can leave it. It does not matter. I need to look up points for this. Okay, so in part A, this was worth 2 points. It was 1 point for your zero slopes, and then 1 point for any non-zero slopes. This was also worth 2 points. Pretty typical, one for your tangent line and then one for your approximation. And this was worth 5 points, of course. So it was one for separating your variables, one for each of your antiderivatives, one for finding your plus c and writing plus c, and then one for actually getting to your final answer of y equals. All right, thanks, guys.